I'm Brent Breithaupt. I'm the regional paleontologist for the Bureau of Land Management in the Cheyenne office. As a regional paleontologist, I'm mainly focused on the protection, preservation, management of fossils throughout Wyoming and the neighboring state.
My name is Emmett Evanoff, and I'm a professor up at the University of Northern Colorado in Greeley, and also a research associate with the University of Colorado Museum here in Boulder. I'm also a research associate at the Denver Museum of Nature and Science.
My name is Whitey Hagedorn. I'm a curator of geology here at the Denver Museum of Nature and Science. Ammonites are one of the most fascinating fossils in all of Earth history. This big beauty is a cousin, it's an ancient cousin of the squid and the snails. Ammonites have a separate chamber. Each part of their shell is a separate chamber, and the animal lives in the last chamber, and as it grows, it adds a new chamber which gets bigger and bigger and bigger as it goes around. Each chamber was connected by a narrow canal in which they could pump gases or fluids, kind of like a bubble or an air balloon, to help them rise or fall in the sea. And they connect the chambers and strengthen them by creating these zigzag patterns or sutures along the walls of each chamber. Ammonites had big eyes. They swum upright, like this, with their tentacles extending out here, and then moving backwards, like that.
The Kremling Cretaceous Ammonite locality is one that's very, very unique because of the diversity and the amount of fossils that are found there.
What's important about that is, why is this concentration there? These were open sea predators, okay? They lived in the open air. It's a time when Colorado and the western interior had a seaway that extended from the Gulf Coast all the way to the Canadian Arctic. The Kremling site was a brooding ground. This is a place where the females mated with the males somewhere in the water. They found the appropriate seafloor bottom. We're at the mouth of a delta, and the delta is bringing out a lot of sand, a lot of sediment, things like that. It gets carried out into the ocean somewhat. Currents in the ocean distributed onto the bottom makes this nice firm substrate for the ammonites to lay their eggs. And the other thing is that it's a wonderful place for nutrients, because they're bringing in nutrients from the land coming into the area, so there's plenty of food sources for the young. Here we have literally hundreds, if not thousands, of ammonites in one area. And in the back there's a mosasaur, and the mosasaurs ate these things. And if these things were sitting there, why isn't it they're not being predated by the mosasaurs? What I think is that they were a little bit somewhat deeper, maybe as much as 30 meters or more, and the sediment was actually murky, and what these guys could be down there, the conditions were such that the big mosasaurs couldn't see them. There's also some evidence from the trace fossils that we don't see shallow, more shallower water type of organisms that make burrows and things like that. These things seem to be a little bit deeper, simply because less currents wouldn't batter the egg cases, and modern squids oftentimes like laying their eggs down, and so do octopi in fairly quiet waters.